silver nitrate solution, how many grams of precipitate is formed? All right, how about we give y'all 3 or 4 minutes to work on this and see how far you get. Try your hardest.
I don't want to look up and down. Take a picture. Yeah.
Yeah, that works. You can take a picture on your phone, copy the picture in your camera roll, and then press paste on your iPad. That works too.
I don't do that either.
Sounds like you just don't want to do the work.
I don't.
Silly stuff. 2 minutes. Don't worry. Started 2 minutes ago.
No talking, quizzes and sessions.
Found graphing calculator. Please.
What?
Confirm it. Sophie, how are you doing? 1 minute. Person who finishes first gets the rest of my lollipop. What are we laughing about? This is a no fun zone. All right, time. And time. All right. So how far were you going to get? I'm all ears.
Not that far.
Where did you, okay. What about you, sir? All right, was there any interesting word or ideas that came to mind when you first read this problem? Think. What?
Maybe serious.
That one was.
Centimeters cubed?
Yeah.
See this, I knew this would throw y'all off, but the conversion is 1 milliliter equals 1 centimeter cubed.
It's the same exact thing.
All right,
It's so easy.
so that's one thing that could have thrown you off. But the thing that we should have thought about as soon as we saw this problem is that it gives us information to find the moles of both reactants. When it gives us information to find the moles or grams of both reactants, what should we immediately think about? Say it with your high with pride. High with pride. Limiting reagents. There we go. So guess what? That was the first thing I thought of as soon as I saw this. And I think we should get into a habit that ask yourself, is there a limiting reagent? Because if there is, you got to find it and then go from there. Don't be like Rish and forget to find the limiting reagents on exam 2.
You actually did do that. That was the one question I missed.
Yeah, embarrassing. Anyways, just kidding. All right, so let's first find it's specifically talking about the precipitate, so we're concerned about the highlighted product that works. So let's find the moles of precipitate formed from each reactant, and we'll determine which one the limiting reactant is. So this is, we know molarity equals moles over liters. So we do molarity times liters, this will give us our moles. So 0.4325 liters. I just got this number from here because it's supposed to be in liters, but right now it gave it to us in milliliters, so we can convert that to liters. And multiplied by 2.5 molar gives us 1.08125 moles of sodium sulfide. All right, let's do it for the second part too. So we use, and we have to realize that centimeters cubed, 1 centimeter cubed is equal to 1 milliliter. And then from there, you can just go through with the rest, go on with the live. So this would be 0.3713 liters multiplied by the molarity, which is 1.5 molar. This should give us a number of approximately 0.55695 moles of AgNO3. All right, from here, do you think if I were to let you continue on, do you know what to do at this point? What do we do here? What's the next thing? Spoiler alert, okay, I'm just kidding. Okay, so yeah, so she said identify the, yeah, so it convert to the moles or mass of silver sulfide, like you said, find the limit. Okay, so I'm gonna do that part in red, okay, so we can distinguish. So step 1 was in black. Step 2 is in red. Step 2, so we use the mole to mole ratio. So let's make sure this is balanced. So we need to have a 2 here. And then 2 here to balance this. Okay. So it's a 1 mole of sodium sulfide for every 1 mole of silver sulfide. Will give us our answer of 1.08125 moles of Ag2S. The second part here is going to be for 2 moles of AgNO3. This is from the balanced chemical equation. 1 mole of Ag2S is produced. This should give you 0.278475 moles of Ag2S. All right, with that, which one did we say, or which one did we determine to be the limiting reagent? What's the, just don't say bottom or top, what's the reagent? Silver nitrate is our limiting reagent, perfect. Okay, so now step 3 is gonna be in blue. So we can go ahead and cross out all that because we're not gonna use that, we're only gonna use this bottom one. Knowing the molar mass of silver sulfide. It is, looking at your periodic table, it is 247.736 grams for every 1 mole of silver sulfide. And that should give you a number. Anyone else get an answer? Yeah,
69.
What?
I didn't want to spoil it.
yeah, 69.0 grams. 69.0 grams. Perfect.
So 30.
But
It's so 30.
well, you come to the next problem on my iPad. Thanks. Okay, then keep writing.
I can barely teach her.
All right, are we good on that problem? Any questions on Zoom, in class?
Oh, I can do it actually.
Lydia or Sophie, are we good? Perfect, thank you, Sophie. Any questions in class? My humongous crowd of students,
For people actually,
and there's a lot of people in here.
at least 50.
So no questions? What about y'all in the back? No questions? Okay, we're good. So next problem is, okay, what has Dr. Armand or your professor Davidson gotten to you so far in class?
Davidson went over redox.
Okay, so you should know how to do 13, right? Perfect. So I'll give y'all, let's say 2 minutes tops to do number 13. You can just abbreviate these: oxidizing agent and RA. Hey, Rich, do you want to come do this one? Sure. So you have had a pen. Yes.
We're doing work together. Two
All right.
brains.
I'll ask Dr. Amon if he can do that on the test, and we'll just divide the score by 2.
You're not in his class.
Well, we'll have a talk with Davidson as well.
Your own room.
'We're trying to go to biryani pot.
Possibly.
So good. You know what biryani pot is? Oh, yeah.
You tried it?
It's so good.
Good stuff,
What do you
bro.
get, what do you get from there? Wait, are you done with the problem? Okay, let's finish that first.
Well, I know, cause like my high school was like near
Right, for high school? Please.
Oh, you went to Elford.
You guys are pre-med, that's crazy. We like our health career students, especially Rich. One minute. Do we need more time? Okay, I'll be happy to give you more time if it means you can solve it through. More time, yes or no? Yes, we'll give you another 30 seconds after this minute ends.
Zoom people, let's go to T in the chat if you need more time, a Y if you don't.
So we got our money up.
This guy already got his points back.
I figured they said it's easy like that. Yeah. I'm just kidding. We got DCM on my hand today.
With gloves on.
With love. See through.
Oh.
And time. All right. Pencils down.
All right, anyways, less dramatically, what is the first step in solving this problem? What'd y'all do? What was step one? All right, so Sophie got her money up. She said assigning oxidation numbers. So let's go ahead and do that. What's the oxidation number for this hydrogen? This one right here.
This one.
Plus one. What about this one? This oxygen.
Wait,
Very-
Sophie said 0. I'm not sure if that was a typo or.
Oh. So the oxidation number is actually +1, right? Because the hydrogen has this plus charge. So that would actually make it +1.
In what cases is the oxidation number 0, Rich?
So the oxidation number is actually 0 when it's something like H2, because it exists in its elemental form. So H2, that would be 0 as the oxidation. In this case, it's +1.
It's for sure a typo. That's what, I mean, there's no way it was not. Gotcha, Sophie.
All right, MnO4. What is the oxidation number for this oxygen? Y'all know this one.
So on your take home assignment. If you did it.
It's like 90% of the time this value. -2, exactly.
Oh, you, I know.
And if this was -2, what would make the oxidation number of this manganese right here? Because we needed to get to overall +7. Right. And then let's do this. So oxygen's -2, hydrogen's +1, like we did this before. -8 +6, but there's 2 carbons, so it should be +3, the carbon. Yeah. And then for CO2, again, -2 here, +4. And then H2O, -3 +1. And then your manganese, what's the final oxidation number here? Yeah, there's +2, because that's the charge. All right, now that that's done, what element was oxidized in this reaction? What element lost electrons? So,
Actually, I gained electrons.
Which one?
yeah, because it's going, remember, like, if you have a more like positive, or let's say you have like +3, that means you lost 3 electrons.
Yeah.
Same thing here, like manganese, like technically it lost 7 electrons, and now it has like, it only lost 2 electrons, you know?
So gain, right?
Yeah, so
It would have
gain.
gained 5. Yeah.
And then here, right, the carbon is the thing that would be oxidized, because as you see here, it's +3, so it lost 3 electrons. And then went to +4, so it lost 4 electrons. So it lost like a total of 1 electron, so carbon is the thing that's oxidized. All right, James, what about the thing that's reduced?
Yeah, I don't know now. The compound that was reduced. Can it be a compound that's reduced?
It's usually an element.
Yeah,
It's always an element.
Oh, just reduced? Oh, yeah, manganese.
Yeah, just manganese. That's the one that was reduced. All right, oxidizing agent, this is where it can be a compound. So what's your oxidizing agent? Yeah, because your oxidizing agent has to contain the thing that was reduced. Think of it like an agent, somebody that helps people. So an oxidizing agent is something that helps something gets oxidized. So if it helps something gets oxidized, it didn't get oxidized itself, it got reduced.
Exactly.
So MnO4 minus. What about your reducing agent? What's that gonna be?
H2.
Yeah, that's what is that again? Oxaloacetic acid, something like that, or not acetic acid, just that's oxalate, so something like that. H2C2O4 is what it's called. So an important thing to remember is that these two, your oxidizing reducing agent, can only be reactants. They can't be products in the problem. Like they can only be reactants. Oxidizing agents and reducing agents are only reactants. So right, y'all pretty much have the money up. Oxidized C, reduced Mn. Oxidizing agent is your permanganate ion, and then your reducing agent is H2C2O4. All right, any questions on that? Right.
Number 14 and stuff after that is getting into chapter 5.
Have y'all done that yet? Gases, gas laws, Hubner, PV was on RT, all that stuff.
Well, we could always go to the problems we didn't do yet. So
Let's do number 6 first. All right, we'll give y'all like 2 minutes. So 6, 8 from B. Just put like S for strong, W for weak, and N for non-electrolyte.
I can do number 6. How much time did we see?
2 minutes.
Y'all went over this already, right? This is like one of the first things he goes over, chapter 4.
I don't want to say this is memorization, but it's
Yeah.
It's memorization in the sense that like you have to recognize certain patterns. So like,
Shout out lunch. So James, what do you get from a biryani pop?
Butter chicken. Creating the order. Like blank, but like I eat there. What do you get amount?
Get chili chicken,
Chili chicken?
bro. It's the best thing on the menu. Well, snap crackle pop. Sorry,
Is it
guys.
hot? Like really hot?
Not really. I also like the chicken 65. Oh, that's pretty good.
Chicken 65.
Rich, what's the meaning behind the 65?
actually, oh, that's why it was invented in the year 1965. That's why they call it chicken 65.
That's great.
And then they say like some people say like it's been marinated for like 65 days or something.
That's cap, bro. I would not eat chicken that's been marinated for 65 days.
Chicken was chopped into 65 pieces.
Wait, what? All right. Time is up. For number 6A. What did we get on this one?
Strong.
So James says strong. But just because James went to health careers doesn't mean that's right. What do y'all think over here? Non-electrolyte? And why do you say non-electrolyte? What?
It's not,
It's not?
Yeah.
It's not what?
not an electrolyte.
All right,
Calcium chloride, right, can be considered a salt. And salt, if you put it in like certain drinks, it can act as an electrolyte, like Gatorade has electrolytes. So yeah, calcium chloride is a salt, right?
yeah,
So
so,
therefore it is an electrolyte.
so let's start with the general overview again of what strong electrolytes are. I'm abbreviating because I don't want to spell so much. So strong electrolytes consist of strong acids, which there are 6 strong acids that we should memorize. So I'm gonna abbreviate that strong A. Strong bases. And soluble salts, okay, so. Soluble salts. All right, weak electrolytes, you get the gist, are going to be, believe it or not, weak acids and bases, so weak acids plus weak bases. And that's pretty much it. Strong or non-electrolytes. Are things that do not dissociate, so like sugars.
Organic or that falls into-
Yeah, so organic things, so such as like methane. CH4. Not specific, that doesn't just apply to methane, it's a bunch of organic things that don't dissociate when put into solution. And also insoluble salts. Yes. So the important thing to realize for the soluble salts and insoluble salts, you might be thinking, how do I know when it is soluble salt or insoluble salt? That goes back to something that you should have started memorizing, called solubility rules. Okay? So calcium chloride, it's definitely an ionic compound, right? Because you have calcium cations bonding to 2 chloride anions. And we know Cls or chlorides are generally what? Soluble or insoluble? So chlorides are generally soluble. And there's a few exceptions that include mercury, copper +1, lead 2+, and silver +1 or silver. So these are the exceptions for your chlorides. Does calcium appear to be one of those exceptions? No, it does not. So calcium chloride is a soluble salt. If it's a soluble salt, it falls under a class of strong electrolytes, all right? So we'll put a S here. HNO3, what is HNO3? In terms of the name of it, what is it? Say it, put in the chat. Nitric acid. Now, if we memorized our 6 strong acids, we would have known that nitric acid is one of those strong acids, meaning when you put it in water, it completely dissociates into H+ and NO3-. Okay, so if it's a strong acid, it falls under strong electrolytes. So we have strong here. What about ethanol? What do you say, James? Non-electrolyte? What do y'all think?
It's got an OH, right? So I'd consider that like a base or something.
So for this class, we don't consider alcohols like this to be acids, and we consider them to be non-electrolytes. Also, because if you were to put this in water, if you put ethanol in water, it's miscible, it mixes together, but it's not going to dissociate into ions. So that's an important thing.
Absolutely booze, it's ethanol and water.
Yeah.
So, yeah.
So that's what we have here is a non-electrolyte soapy, and for everyone, I know, I said soapy because you put that it was a weak acid. So technically you could be right in certain sense because that H does have a little bit of an acidity, some acid strength to it, but.
You don't have to worry about that until like Gen Chem 2.
And okay. Or. But yeah, so for this class, if you put it in water and it doesn't immediately dissociate like ethanol, it's gonna be, it's considered to be a non-electrolyte, okay? Does that make sense? What about formic acid? Strong, weak, or non-electrolyte? What do y'all think over here? Non-electrolyte, why non-electrolyte? What?
You just said the other one.
So Valedia says weak. James, what do you say?
Yeah.
Weak, what do you say? You thought it was what? Weak? And why do you think it's weak?
Acid, right?
Yeah, so if we memorized our strong acids, we would know that formic acid is not one of the 6 strong acids. Therefore, if it's not one of the 6 strong acids, it must be a weak acid, right? If it's a weak acid, it falls under weak electrolytes, so put that there. What about potassium hydroxide? Potassium hydroxide. What did y'all get over here? Weak base, you're close. It is a base.
Strong base.
It's a very strong base. So some people might get mixed up and say, well, why is ethanol not a strong base? Because it has the OH. See, ethanol is covalent compound. It only has covalent bonds, even the OH is covalently bonded, whereas the potassium hydroxide is ionically bonded between your potassium and your hydroxide ion. Therefore, that means it's, and we know hydroxides are very, any sort of hydroxide that's soluble is going to be considered a strong base. Something that's, let me see. So to answer this, the answer would be strong, but let's see if I can think of something. So SN. What do we say about 10,2 hydroxide? Strong base, weak base. Strong. So we have 1% say strong. James, what do you think? Okay, weak. So this was actually a trick question because tin 2 salt hydroxide is an insoluble salt, which would make it a non-electrolyte. So we got to be careful about those two. So you can have salts that are strong soluble salts, or you have insoluble salts. If it's a soluble salt with a hydroxide, it's automatically a strong base. If it is a insoluble salt with a hydroxide, no matter what, if it's insoluble, it's considered to be a non-electrolyte, okay? So yeah, I'm sorry, I tricked y'all a little bit. But what the heck was, how did that end up there? Look, there was another one that was hiding behind that thing, apparently. So you can do F. And we already said this is, so go ahead and let's do F. Got another person. Alyssa. Nice. What do you think, Rich? What are you thinking about this one? Wrong answers only.
So it's pretty. Oh, lead, right? You can. So sometimes you use it in like certain reactions.
You put it in your friend's water.
Yeah.
I bet. Did you just confess to a crime?
Yeah, I don't know. That's a crime. Flint, Michigan does it all the time.
Good. All right. Sophie, Alyssa, Valeria, what do y'all think? Put it in the chat, or you can unmute yourself.
Got a 1 in 3 chance. Generate.
Non-electrolyte. Valeria says non. Do we agree with Valeria? Two ladies in here say non-electrolyte. And what does James say?
Say weak.
James says weak. What about the other? I'm gonna let everyone in the back of the room just, you don't have to answer, but what about Alyssa and Sophie? What do y'all think?
I'm gonna go with weak as well.
Okay, okay.
We got 3 for weak, 2 for non,
3 for non.
3 for non. Oh, so it's all tied up.
It's tied up. I guess Rich will be the tiebreaker.
Otherwise,
I will say, I do have to agree with the non-electrolyte. I think they make a compelling argument.
All right, so Rich says non-electrolyte. And let's figure out why. Let's look at what kind of compound is it? Is it a covalent or ionic compound? To first, like, what's off the bat? What is that answer to that question? Ionic or covalent? Is there a metal?
Yeah.
Then it's most definitely ionic. Okay, so it's ionic. Ionic compounds can either be, believe it or not, soluble salts or insoluble salts for this class, okay? So what did we say earlier about chlorides? Are they generally soluble or insoluble? Sophie says, we're gonna pretend Sophie said insoluble with regards to chloride. So they're insoluble with the exceptions that they are generally soluble with exceptions that make them insoluble, such as silver plus, lead 2 plus. What is the next ones? Mercury, Hg2 2 plus, and then copper 2 plus 1. So those are the 4 exceptions that will make chloride insoluble. If you're not, and then we can do our reverse crisscross here. So we have our 1 here. When are we gonna trademark the reverse crisscross, Rich?
So first crisscross. No, I use a loop personally.
This guy. All right,
That's all I want.
so when you identify the charges using the reverse crisscross or the reverse loop-de-loop, you get that lead has a 2 plus charge. And whoa, what do we have here? One of the exceptions that makes chlorides insoluble is a lead 2 plus. So with that being said, lead 2 chloride is insoluble. If it's insoluble salt, it must fall under the category of non-electrolyte. Boom. How were those questions? Anything trip y'all up? Do you feel like you learned something from one of these, at least one of these questions? That's the goal here. Always striving to learn more every single day. Anyways. There's no questions, we'll go to number 7. Rich got number 7, and we'll give y'all 3 minutes to work on number 7, starting now. Just slide it up.
Should be a CA, by the way, not BA. We'll change that right now.
Didn't change the stoichiometry, but it will change the molar mass, that's for sure.
Yep.
And if I just strip that up,
Her.
okay, that's great. How about it?
Really want it?
Not anymore, not anymore. That's a big no-no for me.
You know, like blue?
No,
Red?
no.
You all get done, you can solve out this problem.
Rich, why are you drawing triangles, bro? Bro, I'm trying to get some chili chicken in my system after this. Yeah.
All right, you can try that out if you're done with the problem, of course.
Come on, Rich. What do we got here? Is that calcium? Is that diatomic calcium?
That's not diatomic calcium, should be carbon dioxide.
Oh. Hey, what's a stronger nucleophile, organolithium or a Grignard reagent? Assuming the alkyl group is the same.
I'm going with the lithium,
Why?
because you know, the Grignard has to insert itself in between the, so you have an alkyl halide, insert itself, the magnesium inserts itself between the alkyl group and the bromine,
Yeah.
making a less strong nucleophile, whereas the lithium is just an unhindered carbanion.
I'm in there carbon anion.
Yep. Because technically, if you have like, say there's an alpha. You have this.
Put your fingers on there, Rich.
So you have that, it's really the same thing as this.
Not really. There's not a carbon ion. There's no carbon ion. It will never be a carbon ion. It might be close to a carbon ion, but it's not going to be a carbon ion.
Although that and this were the same thing, because you can rewrite this as that and this.
See, that's what Janice says. You're gonna take Janice's word.
I mean, Yoshimoto takes Janus, that's all I care.
No, yeah, you're right. The organolithiums are more nucleophilic. All right, time to get on with the question. Who was able to finish? Yes.
High with pride, raise your hand devices.
How are you doing the math? Oh, where did you put your iPad?
So smart.
Oh, for sure.
All right, so what mass in grams of calcium nitrate is required to produce 350 milliliters of whatever point molar solution? What's our first step? So let's do a game plan right here. Step one, convert to moles. But we don't have moles. How are we supposed to get it?
What equation do we call that?
Clarity.
Exactly. Our molarity equation.
So moles equals molarity times volume. Wait, but our volume's in milliliters. How do we get into liters? How do we do that?
Times 1,000, so 350,000 liters.
You just moved the decimal 3 times, so it's 0.0.
Which way?
Huh?
Which way do you move the decimal?
To the left.
There we go. So it's 0.35 meters. So 0.35 times, this looks right, 0.0850 molar. So when you solve that out, you get 0.02975 moles of calcium. Wait, but the problem asks for mass, we only have moles. What do we do now? How? What's ONS?
On us.
What's the value?
Oh, but it was. 204.164.
204.16. Interesting. So calcium, right, is 40. Nitrogen is 28. There's not 28, but there's two of them. 6 times 6, 96. So 5 carry 5, 7,
64.
164. And that's what matches here.
Where did you hear me?
164.078 grams. in 1 mole. So if we solve that out, we'll get an answer as 4.88 grams. So step 2, convert.
Careful. I wish I know that.
To grams using. This is of CaNO32. All right, that is the end of the problem. Did y'all get it? Did y'all get that answer? 4.88. Pretty sure, not 1 decimal point higher, not 1 decimal point lower.
This kitty.
4.89, we would count that wrong on the test, okay? I was kidding.
All right. Any questions on Zoom? Y'all have any questions over here? Zoom people have their money up usually. That's what I've noticed.
They're probably just in bed too. Alrighty,
There are no further questions.
what was the answer to the other OChem question you gave us?
Oh, so the answer to the OChem question. So what happens is you have a Grignard reagent,
Wow.
MgBr,
Doesn't work.
and then reacted with CO2 and H3O plus. So all you have to do is predict the products. So if you do that, you're just gonna get fat little carboxylic acid on here.
Said that.
There we go.
Yeah, she did say that.
Draw the mechanism.
It's like you put that to the right and then bring it in.
Not far off. So this happens, you're gonna attack this, that goes here, that moves over there. So then this is on the molecule, then you just take a proton, and then that's how that works. That's here. H3O plus, you get the idea.
I just told you that.
All right, go ahead and start on number 8A. And 8, and then, yeah, you get it, sorry, it looks like there's already like 2, if Rich could find the question. There we go. 50 milliliters, who's using? That's crazy. James, you're in our boss class, right?
Today.
That's what I said. Anyways, you should stand up in front of the class tomorrow, or whenever you have class, and say, you all should come to Dylan and Rich's TA sessions. Just because I'm trying to see every chair filled in this room, like last semester.
Oh, was it really?
Yeah, last semester it was crazy.
Aw,
Yeah,
I'm so disappointed.
There were these people in the room in the front that would not shut up. So yeah.
I want to sit in front.
What happened? It's on the blackboard too, y'all's.
yeah. Yeah, I'm gonna start checking the activity of the students on Blackboard. How many people log in every week?
I mean, y'all have to for the video assignments.
Not even half the people do the video assignments.
Y'all turn in your Alex coins, by the way.
Can we save them?
No, they get. I'm just
No, they
kidding, I'm just
don't.
kidding, yeah, you can roll them over.
Yeah, but it's a pain in the butt for us. Because some people last semester, they were like, let me use my 55 Alex coins on these like 10 assignments. The process for putting them in took long.
We'll forget to process it.
Wow.
I only had like 9 to do this time and it took me like 30 minutes still.
Yeah, haven't
But, like,
done it yet.
I want to see.
I mean, if you don't have enough,
No, I do. I have more than.
Great.
Most of what we have to do is for like quality assurance purposes. Like
Yeah,
actually,
like record tracking. So people can't say, they never used my assignment or my Alice points for the assignments. On Zoom, put a K in the chat if you're done, and an A in the chat if you're not done and need more time. K as in uh,
Ciao.
A as in potassium.
A as in
Apple.
aluminum.
A as in alpha. What is the military thing? Alphabet for K.
Alpha, Beta, Charlie, Foxtrot,
K. Alpha, beta, delta.
I used to know King Koala, probably.
I don't know about that.
Who are the koala or kangaroo? Height,
The military is offering free cars for anyone that enlists in the next few weeks. Might have to do that. It's kilo.
oh, like, yeah,
Kilo.
they use, Gen Chem and everything.
Exactly. Oscar. Okay,
All right, we're gonna go ahead.
Wait, I'm almost done.
that's fine. Keep working and you can check with our answer. Okay.
All right, we're gonna be doing our thing like 21. So, what mass in grams of potassium ions are there in 50 milliliters of 0.75 molar? Well, how do you name that thing again? I forgot.
You got it, James. I see it. I see it rolling off the tongue.
See those neurons firing?
Dang, that's great.
Potassium sulfate. Yeah.
Good job, Sophie.
All right. So, step one. Step one. Convert to moles. But wait, we don't have moles. So how do we convert to moles?
I feel like you're on Zoom, we can't hear you.
Last semester, there was a group back there talking, and the Zoom people were like, they can't hear.
I can move back.
Yeah,
Maybe it has a-
those little green things are mics. All right, anyways, back to the question at hand. How do we convert to moles with what we're getting?
One play. See, right?
Yeah. Wait, what?
Multiply the ML and, or actually convert the ML first to liters, and multiply it by the 75.
Yeah, so you got 0.75, and then you multiply that by 0.05 to get an answer of 0.0375 moles of potassium sulfate. All right. I have my fingers on it, so I don't know why. A2SO3. Now, how do we get to ions in here from what we're given? You all know?
How do you not do it?
How do we get to ions? That's what I'm confused about. I'm honestly where the ions are.
Yeah. I'm confused. James, how will you do this, James?
We all are actually.
No. We're just trying to get y'all that name. Like when I say like, I got no clue, I do have a clue.
You know every-
Moles, but I-
He has every clue.
Yeah.
So you're saying use that avocados number? What if I do this though? In every 1 mole of K2SO3, there'd be 2 moles of potassium ions.
All ratios, bro.
Yeah.
Ratios, it's always.
This is an ionic compound, right? So for every 1 mole of this, it makes sense that there's 2 potassium ions and 1 sulfide ion. And now we go ahead and do this. 1 mole of potassium has 39.098 grams. So if we solve that out, we get 2.93 grams. So this is the mass in grams of potassium ions. All right, that was part A. Now time for part B. How many potassium ions are in the solution? What do you do here? No, you know it, James.
No, you know it, James.
So, yeah.
All right, so let me try out this culture, all right? So there's 0.0375 moles of K2SO3. That's something we got solving this right here.
Is it
On this problem.
2 or 3? You put 2 here.
It's a 3.
Yeah, that's a 3. I think it messed up as a so 3. So 3 right here, right? But we can also do our same thing. We can do those mole ratios. So for every 1 mole of K2SO3, there's 2 potassium ions. 2 moles of, yes, 2 moles of K plus. So for 1 mole of the entire thing, there's like 2 moles of potassium ions. There's something where like, if you have like a total unit, like there's 2 moles of potassium for every 1 like thing of the compound.
It's kind of like saying for every 1 carton of eggs, there's 12 eggs inside, right? In this case, the carton is the 1 potassium sulfite, and the eggs would be the 2 potassium ions inside of that carton, okay? So that's a similar ratio of what we're explaining here. Instead of eggs and cartons, it's,
Moles and moles.
yeah, chemicals, ions, stuff like that.
So we have this here, we're in moles of potassium ions. Now to get how many are actually there, what number do we use? Avocado's number. So for every 1 mole of potassium, there is 6.022 times 10 to the 23rd K plus ions. So if we solve that out, we'll get 4.5 times 10 to the 22 K plus ions. And that's how many are there.
That's it.
That's it. That's all you do.
That's it. What do you think about that, James?
I think it's pretty good. It's pretty good.
Pretty good, pretty good. Kind of like that butter chicken.
Dude. It's so good. And it's not, yeah.
Samosas, yeah, those are good.
You should see Rich, whenever we go, he just eats straight jalapenos.
Oh gosh.
Yeah.
Crazy.
It's crazy.
All right, speaking of jalapenos, y'all can jalapeno up out of here. And yeah, that's all we have for y'all
Yeah, baby.
today. We will refine this review, send it out. There's like 2 questions we want to add, stuff we want to change up. So yeah,
Thank you very much, Sophie, and everyone else that was able to join our session today. We really appreciate everyone that's able to make it out. Thanks for the live thoughts.